Hello, my lovelies. It's Susanne, and today I want to show you all the rules that you need to differentiate your functions. We're going to take a look at the constant rule, the power rule, the product rule, the quotient rule, chain rule, so all kinds of rules in this one video. Let's start with the constant rule, the easiest rule that we have. So if your function looks like this, f of x equals 5, so just a number, here's no x in here, just a number, then your derivative is always just 0. That's the best case that can happen. So if you have just a number without a variable, your derivative is always 0. Same thing here. So it doesn't matter how complicated the number looks. Negative the square root of 2 is just a number. Not a very nice one, but just a number. Here is no x in here at all. So the derivative vanishes and we only get 0. Same thing here. It looks more complicated, e to the power of 400, but here's no variable in here. Here is no x in here at all. So we know now the constant rule tells us that this vanishes and our derivative is going to be 0. Okay, that was the easiest rule. The power rule. Now, if you have an x in your function, and let's say you have something like x to the power of a number, then the rule is the following. You take your exponent, the 3, and write it in front of your power, and then you have to decrease your exponent by 1. So instead of x to the power of 3, we now write x to the power of 2, and this is the rule. The same thing here. It doesn't matter how large this number is. We have x to the power of a number. So the rule is we take this number, the 1000, write it in front of our power, and then we decrease the exponent by 1. So instead of x to the power of 1000, we only have x to the power of 999. So the formula for this rule is that every time you have something like x to the power of n, your derivative is going to be n. You take the exponent and multiply it by x to the power of, and then you decrease your exponent by 1, so your exponent is n minus 1 then. This is the formula, but what we just did is what it means then in reality, even if you have a negative exponent. But this is the structure. We have x to the power of a number, so x to the power of a number, which means you take this number, so you take the negative 7, and then you multiply it by x to the power of, and then you decrease your exponent by 1. So negative 7 minus 1 equals negative 8. You have to be a little bit more careful with the negative numbers, but this is the rule. Okay, next rule, constant multiple rule. This time we have x to the power of 5 here, so we now know how to differentiate this, but there is a 3 times in front of my power here. And every time you have a constant multiple or a factor in front of your function here, the rule says you just keep this factor. You don't change anything. So if you have 3 times, then you just keep the 3 times. Don't change anything. Also an easy rule. And then you have to differentiate the x to the power of 5, but we now know how it works. We take the exponent, the 5, and multiply it by this power here, but we have to decrease our exponent by 1. So we have x to the power of 4. So 3 times 5, you can calculate this then, which equals 15. So instead of this, you can write it as this as well, and this is your derivative. The same thing here, we have the square root of 3 times t to the power of 4. This time our variable is called t, so always check this. Here it was x, here it is t. Can happen, nothing bad about that, but t is in here. But in front of our t part, we have a number times our t part. And we know this is just a factor, so we don't touch it. We just take the square root of 3 and write it in front of our part here. And then we have to differentiate this. We take the exponent, the 4, write it in front, and decrease the exponent by 1 so that we get t to the power of 3. And this is your derivative. Why is this the same thing? Why do we have a factor here if it says x to the power of 8 over 6? Well, we can write this in a different way so that we can really see the factor. I'm not a fan of having your variable in your fraction anyway, so I always separate the numbers from my variables. So in the numerator here, I have 1 times this x to the power of 8. So if I want to separate my variable from the fraction, I have 1 over 6, and then I can multiply it by my variable by x to the power of 8. So now we can see, oh, this is a factor, actually. So 1 over 6, we don't touch it. It just stays the same when we want to find our derivative. And then we have to differentiate this part, but now we really know how it works. We take the 8 and multiply it by x to the power of 7 then. Okay, this was the constant multiple rule. And we take a look at the sum difference rule. This time we have a minus and a plus here in between our expressions. The minus is the difference, the plus is the sum, and we don't know yet how to differentiate this. But the minus and the plus separate our expression here into 3 parts. We have this part here, and this part here. And the rule then says differentiate each part individually. So start with your first part, then after you're done, differentiate the second part. After you're done, take care of the last part. So fortunately, pretty easy. So let's start here. X to the power of 2, this is a power, so we take the 2, write it in front, and decrease the exponent by 1. 2 minus 1 equals 1. We don't have to write down power to the power of 1, so we can just write it like this. So 2x is the derivative of x to the power of 2. Then we write down the minus, and now we just take care of the second part. Here we have 5 times x, so we know, okay, the 5 is a factor. We don't change it, we just leave the 5 as it is. And then we take care of the x. This actually is a power as well. It's x to the power of 1. We just usually don't write this exponent, but it's a power, so let's apply the power rule. We take the 1, write it in front, and decrease the exponent by 1 so that we have x to the power of 1 minus 1 equals 0. Before we keep going with the third part, let's simplify this a little bit, because x to the power of 0 doesn't look that nice, but the good thing is that every time if you have something to the power of 0, this whole thing is always equal to 1. So we have 5 times 1 times 1, so this times 1, I don't have to write this down, but just as a shortcut, if we take a look at this derivative here again, here we only had x, so I'm going to erase this to the power of 1 again. So every time you have an x in your function, so not x to the power of 8 or something, just an x, your derivative is going to be 1. So what you can save in your memory, that if you have 5 x, so just a simple x in here with nothing fancy around it, then the rule is that this x will vanish because the derivative of it is 1, and the only thing that stays is the number in front of your x, so the 5. So 5 times 1 is just equal to 5, so this is the derivative of this part. What about the plus 7 here? We also have to differentiate it, but this was the first rule we had today. Here we don't have any variable in here, so there is no x in here, which means this is a constant and it will vanish. So you can write down a plus 0, but you don't have to. You can just leave it like this, and this is your derivative. Okay, next rule, product rule. Super important rule. What is it? We have a product here, x to the power of 3 times x to the power of 5. The important part is that in the first part of your product, you have something with x, and in the second part of your product, you also have something with x. So every time you have something with x times something with x, you have to use the product rule to find the derivative of this function. So let's say you have something like e to the power of x times x, which means we have something with x times something with x. Yes, here we would need the product rule. Same thing with sine of 2x times x squared. We have something with x times something with x. Here as well, we would need the product rule to find the derivative. We would not need this rule if you have something like 3 times e to the power of x, because yes, it is a product, but in the first part, there is no x in there. Only here we have an x, so this here is not an example where you have to use the product rule. You can just see this 3 as a factor, and then you know, oh, the 3 just stays the same, and I only have to find the derivative of e to the power of x. So be aware when you have to use the product rule. The thing with this example here actually is that I picked this example because it is easy enough so that we can just apply all the rules we've just seen. We don't need new rules instead of except for the product rule. But the thing is that you don't actually have to use the product rule for this example here, because you could just simplify this here first before differentiating it. So if you have something like this, then please simplify this first. So we have x to the power of 3 times x to the power of 5, which gives us x to the power of, and we are allowed to add the exponents. So 3 plus 5 equals 8. So you would write it as x to the power of 8, and then you know you don't have to use a new rule. We know that this is the power rule. But I chose this example to show you the product rule anyway. So if we leave it like this, and we know, okay, we have a first part where there is an x in here, and we have a second part where there is an x in here, then the product rule says, call your first part u and your second part v. So everything in front of your multiplication symbol is your u, and everything after is your v. So in our case, our u would be x to the power of 3, and our v would be x to the power of 5. Then you find the derivative of your function by differentiating u first and multiplying it by v as it is, plus you take u as it is and multiply it by the derivative of v. So we need u, v, u prime, v prime. We already have u and v, but we don't have u prime yet and v prime yet. So let's differentiate this. We take the exponent, add the 3, and then we only have the 2 here. Here the same thing. We take the 5, and then we have a 4 here. Let's insert everything into the product rule here. U prime is 3x squared, so we take 3x squared. We multiply it by v, so v was x to the power of 5. Then we add u is x to the power of 3, and we multiply it by v prime is 5x to the power of 4. This is our derivative. Of course, you can simplify it usually more, but this is the product rule. And there is a quotient rule as well for fractions. So here it is the same. We have a big fraction. In the numerator, we have something with x, and in the denominator, we have something with x. And every time that is the case, you need the quotient rule to find the derivative. But it's very similar, and the thing is that this time we call the numerator u, and we call the denominator v. So in our case, u is 4x squared plus 3, and our v is x to the power of 5. And then the quotient rule is a fraction. This time we have u prime times v minus u times v prime. So it's very similar to the product rule where we had a plus here in between, but this time same things but with a minus. And in the denominator, we take the v that was there and square it. This is the quotient rule. So we already have u and v. We know we need u prime and v prime as well. So let's try and find u prime and v prime. Let's differentiate this. We have 4 times, so the 4 times stays. Here we take the exponent, the 2, and decrease the exponent then by 1. We get a 1 as a result, or don't have to write it down. And then the plus 3, there is no x in here, so this is just a constant and it will vanish. So we have 4 times 2, we can write it as 8 then, so that we have 8x in total for u prime. Same with v prime. Here we take the exponent, the 5, and then we have x to the power of 4 here. Let's insert everything into our formula. U prime is 8x times v is x to the power of 5 minus. My u is this whole thing, so please, every time you have a plus or minus in between here, always write it in parentheses so that you take the entire u as it is, this whole thing, and then multiply it by v prime, which is 5x to the power of 4. Don't forget to square v in the denominator, so v was x to the power of 5, and this thing always needs to be squared. It's something you easily forget, but yeah, this is the quotient rule. And also here, of course, you have to simplify these things then, but this in general is your derivative. And then we have our last rule, our lovely chain rule. People love the chain rule, or not. But the problem with the chain rule is that it's not so easy to see when you have to apply it. So in our example here, we have something in parentheses, x to the power of 4 plus 5, and then all of this to the power of 7. So this time we have something inside parentheses, and then we have something outside of parentheses. So we have an inner function and an outer function. And every time when you have a function in another function, then you need the chain rule. Same thing, for example, if you have the square root of 2x minus 1. Then we have something in the square root, so inside, and we have the square root outside. So we have a function in another function. Or if you have sine of 3x, for example, then here we have a function in the sine, so in this outer function. The green thing is always the inner function, the orange thing is the outer function. So really work with colors. I think it helps a lot to see what you have to do here, because the chain rule itself is pretty easy. It just says take your inner function, so the green thing, and differentiate the inner function, and then just multiply it by the derivative of the outer function. That's the chain rule. Inner derivative times outer derivative. So in our case, our inner function, the green part, everything that is in the parentheses, is x to the power of 4 plus 5. And the outer function, the orange part, is everything that is outside. So that is the parentheses and then to the power of 7. This is my orange part. Usually I just highlight that there is an inner function in here. I don't write it down because it looks way more complicated, but I just highlight inside there is this green thing. We don't have to really know what the green thing is, but just be aware there is something in there. But for the chain rule, we just need to differentiate these things now. So let's start with the green inner function. Let's find the derivative. What is it? Well, we have a sum, so we know we are allowed to differentiate this, and after that, then this. So x to the power of 4, we take the exponent, the 4, and then we have x to the power of 3. Then we have the plus, but the 5, there is no x in here. So we know this is just a constant. This will vanish. So we don't need the plus 0. We can just leave it like this. And now we also have to find the derivative of the orange function, so of the outer function. Here we have something to the power of 7. So something to the power of 7, this is a power. So we use the power rule. We take the 7 and write it in front of our thing. Okay, our thing is these parentheses with our green part in here. But then our new exponent is going to be a 6. So the power rule here is 7 times what we had, and then to the power of 6. Okay, so let's apply this then here. We take the green derivative, so 4x to the power of 3, and multiply it by the orange derivative, which is 7 times, then these parentheses, and to the power of 6. The problem now is, what is this green part? I cannot just put this in here and say, this is my derivative. Well, the green part is just what the green part was. So from the original function here, the green part was this. We don't change what is inside. So that is important. Every time you find the derivative of the orange part, so if you want to find the derivative of the outer function, you don't touch and don't change the inner function at all. What we changed was we took the 7 and decreased the exponent by 1. Yes, we did that. But you don't change the green part at all. You just keep it as it is, write it down here, and only take care of the outer things that you do. So never change the inner function if you want to find the derivative of the outer function. These were all the rules. Of course, there are also special functions like the exponential function or sine, cosine, or the logarithm, and so on. I made individual videos on these topics, but this here was really an overview over all the basic derivative rules, and I hope it helped you. If you have any questions, please let me know in the comments. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care!